guys are writing paper 1 tomorrow. So, of course, we will be thinking about you and hoping and praying that everything goes really, really well. Thanks for all of you that sent through questions. What I'm going to do is I'm going to kind of fly through the questions that you sent me, just because I want to try and get to everybody's. I hope I managed to do that with the time that we have available to us. Okay, so if you are stuck anywhere, please do ask me, but I'm apologizing now for working quite quickly. All right, so this was something that was sent through today as well. It's a question about the roots of a quadratic equation. So what's been given to you here is the quadratic equation, and what is inside the root over here, that is your discriminant. That is b squared minus 4ac. All right, and what's important here is that they're asking you to solve for k when the roots are real. So for roots to be real, the discriminant, delta, has to be greater than or equal to 0. So what you would do is you take your expression inside your root, minus k minus 4, and you would make it greater than or equal to 0. That would get you 1 mark, okay, for knowing that real roots are greater than or equal to 0. The next thing is solving for k. So we're going to leave negative k on the other side, and we're going to take 4 over to the right-hand side, and then it's going to change its sign. And now, because we're dividing by a negative, it means that our sign is going to have to switch round. So therefore, k has to be smaller than or equal to negative 4. I've divided by negative 1 on both sides. Okay, so that was the first question I was sent. I hope that's all okay. I'm going to move on to the next thing. Someone, I think it was, I can't remember. The name's gone out of my head, sent me this question, which is quite a hectic question. So I definitely want to try this with you guys. So this is a question about sequences and series again. So here we are given a series. It goes 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, all the way to 5,000. Now they've asked us to write down the series in sigma notation if all the powers of 4 are removed from the series. We didn't practice writing sigma notation the last time that I was with you. If they want you to write sigma notation, they want you to produce this. There's the E, and they want you to fill in the number at the top. They want you to fill in the number at the bottom, and then they want you to put the rule in brackets. That's what they want from you. So it's those 3 things, okay? So this particular question cannot be answered with one sigma notation, right? Because they've said to us, write down the series if all the powers of 4 are removed. So this has to be done using a difference. Okay, so it's going to have to consist of 2 terms, all right? So the first term, let's just make this a little bit bigger. Okay, is how are we going to describe the nth term of the pattern 1 plus 2 plus 3 plus 4 plus 5? Okay, so I've got to use different letters. Let's say I use the letter P. Right, that's how I would describe this particular pattern. Right, so 1 goes in, 1 comes out, 2 goes in, 2 comes out, 3 goes in, 3 comes out, 4 goes in, 4 comes out. All right, so whatever goes in is whatever comes out. So 1 comes out first, so I'm starting with 1. How many terms are there in the pattern? Okay, the last term I want to sub in, it needs to be 5,000. So there will be 5,000 terms in this particular pattern. 5,000 minus 1 plus 1 would give me 5,000. 5,000 would be the last number I subbed in. Now I want to subtract all the powers of 4. So that's going to be any value to the power of 4. So in this case, I'm going to use n. Again, I'm going to have to start with 1. Okay, so now the numbers that I want to remove are 1 to the power of 4. Plus 2 to the power of 4, plus 3 to the power of 4, plus all the way up to a power of 4 that is smaller than 5,000. That actually happens to be 8 to the power of 4. Matrix, 8 to the power of 4, correct me if I'm wrong, but is 4,096?
Yes, ma'am.
Yes, is that right? Okay, so here your pattern is going to be n to the power of 4. The first number we're going to sub in is 1. The last number that we want to sub in is 8. Okay, so that's how you would write this. I know it's 4 marks. It looks like it's a lot. But in this case, obviously having our rule, and then here where we would start subbing in our last value, and again the fact that we have subtracted, where we would start subbing in what our rule is and what the last number would be. Okay, does that make sense to everybody? As I said, I'm sorry, I know I'm rushing a little bit, but it's just because I want to get through everybody's questions. Okay, we're happy to move on to the next thing. So in question 3.2, they say to us the following two geometric series are convergent. So straight away, when they use the words convergent, what are they implying about these two sequences? That you can calculate a sum to infinity. Okay, so when they say determine the values of x for which the sum of these two series is equal to 8, what they're asking you to do is this really, is a sum to infinity of the first series plus the sum to infinity of the second series, and you need to make that equal to 8. That's really what they want from us. Okay, so now how do we write a sum to infinity? Okay, sum to infinity is a over 1 minus r. Okay, a over 1 minus r. Now, let's just go back and establish what a and r are in these particular patterns. Okay, so if we have a look at this first series, okay, a, the first term, is 1. R, term 3 divided by term 2, term 2 divided by term 1. R is going to be equal to x in this case. When we're talking about the second series, let's do it in a different color. That's this one over here. All right. A is also equal to 1. All right. But term 2 divided by term 1 is minus x. Minus x divided by 1 is minus x. Minus x cubed divided by x squared is minus x. So r is equal to negative x in this case. So that is what we want to now go and sub in, okay, over here. All right, so I'm just going to sub that in quickly. All right, so we've got, from our first series, we've got a is 1 over, oh, I don't know if you can see the green, it's horrible. You've got 1 over 1 minus r is 1 minus x. Plus the second one, a was equal to 1 minus r, so it's 1 minus x, so it's going to be 1 plus x is equal to 8. And now we're going to be able to solve for x. All right, so our lowest common denominator in this case, our LCD, is going to be 1 minus x times 1 plus x. So what I want to do is I want to multiply every term by the LCD. So I'm going to end up with 1 times 1 plus x plus 1 times 1 minus x equals 8, and because that's over 1, I've got to multiply it by 1 minus x times 1 plus x. Okay, so now I've got rid of the denominators. Now I'm going to remove all my brackets. It's going to end up being quadratic. I'm going to get it into standard form, make it equal to 0, factorize, etc., etc. Okay, so I'm going to end up with 1 plus x plus 1 minus x. And then here 8, and then this is difference of 2 squared. So this is going to be 1 minus x squared, right? So I've got 2 on this side, 2 left on this side. The x's have cancelled out. And now this is going to give me 8 times 1 is 8, and 8 times minus x squared is minus 8x squared. All right, so if I now bring the 8x squared over to this side, and the 2 over to the side, it would be equal to 6. What I could do, because this is now, it doesn't have a middle term, it doesn't have an x term in the middle. So what I'm going to have to do now is divide both of them by the highest common factor, which in this case would be 2. All right, so that's going to leave me with 4x squared is equal to 3. Now I'm going to have to divide both sides by 4, which means I'm left with x squared is going to be equal to 3 over 4. And now finally, when I work out my answer, I'm going to take the square root on both sides. So that means that, very important, don't forget about this, all right? So when you're taking a root that is an even number, you can have a positive or a negative. So x will be equal to plus minus root 3 over 4. Okay, so either x will be equal to positive root 3 over 2, or x will be equal to negative root 3 over 2. Okay, so that was that question.
Ma'am?
Yes, Karabo.
Yesterday when we were doing it with Mrs. Mary Lee's,
Yes.
she did the 3.1 differently with the powers of 4, the power of 4.
Oh, did she?
Yeah, so
What did she? Okay, what did she do?
well, instead of saying 1 to the power of 4, she said 4 to the power of 1, 4 to the power of 2, like that. And with the where you put the 8 as the ending value, she put 6, and in brackets she put 4 times 4 in brackets into out to the power of n minus 1.
Oh, okay. I see now, this is now maybe a problem with the question, because maybe she and I have interpreted it differently. But if I'm saying, if you're saying if all the powers of 4 are going to be removed, then it has to be the base that's changing. It has to be 1 to the power of 4 or 2 to the power. Those are the powers of 4. 1 to the power of 4, 2 to the power of 4, 3 to the power of 4. So I'm not saying Marilise is wrong, but I think what I've done here is correct. I don't think that what I've done here is wrong. Not that that helps you very much, but I can certainly speak to her about it and see, but that's how I interpret this question. Okay, so for me, all the powers of 4 is 1 to the power of 4, 2 to the power of 4, 3 to the power of 4, 4 to the power of 4, 5 to the power of 4. Okay.
Yeah, okay, man. Thank you.
All right, no problem. Okay, so she actually did this question with you yesterday.
Yes, ma'am, she did.
Oh, I wish I'd known that. Then I wouldn't. You should have stopped me and said, ma'am, she's done it with us.
I tried, but I was scared.
No, you mustn't be scared. That's what you're here for. I don't want to waste your time. Sorry, I didn't realize she had done that with you. Okay, so these were the other questions that I was sent. Okay, so it was this question here on optimization, question number 10. Then it was also this question over here, which is also an optimization question or a min-max question. This is question number 9. Then I was sent this, which is financial maths. And then there was another question that I was sent over here. That's this one. This was on the fundamental counting principle. Okay, so I don't know which one of these you feel we should do first. Is anyone okay? Can I just do anyone? Doesn't matter. The one with more marks first. Okay. All right, so you mean for a single question? Okay, so as far as a single question with more marks is concerned, that would be this one over here. All right, so let's talk about this. This came out of, I think it was 2017 or 2018, I can't remember. Okay, so we are talking about a stretch of road. So the stretch of road is this bit over here. Okay, the road can be described by the function y equals x squared plus 2, where x is greater than or equal to 0. If the coordinate axes or dotted lines are chosen in the diagram. So Benny sits at a vantage point. In other words, he's sitting over here and he observes a car P traveling along the road. They want us to calculate the distance between Benny and the car when the car is closest to Benny. So that means that when the distance, so in other words, when the distance between Benny and the car is at a minimum. Okay, so that is our clue here, that this is a question about min-max, and that we're going to have to derive an expression in terms of distance. We are then going to have to differentiate, make it equal to 0, because the gradient at our turning points, at our maximum or our minimum, would be 0, and then we would be able to solve for x and then go and sub back into our original equation. All right, so what we want to do is we want to minimize distance. So distance formula, distance between 2 points, is described using distance formula. Okay, so I'm going to use it in the square form. Okay, our 2 points that we're going to sub in, it's the distance between here and any point on this particular line. So the 2 points that we are subbing in, this one would be 0 and that one would be 3. And then our other point, P, its x coordinate is x, and its y coordinate is x squared plus 2. Okay, so subbing into distance formula, okay, so it's the change in x's. So I'm going to say x minus 0 squared plus the change in y squared. So here, this is going to end up being x squared plus 2. And then I need to take away 3, and then I've got to square that as well. So PB squared ends up being x squared plus, then in brackets here, I've got x squared plus 2 minus 3 is minus 1 squared. I now need to remove my brackets. So I've got x squared plus, square the first term, multiply the terms together and double it, square the last term, sorry, I left a square off here, and final answer here would be x to the power of 4 minus x squared plus 1. Now, that describes PB squared. So PB will be at a minimum, the distance will be at a minimum, when PB squared is at a minimum. Okay, so that means I can now go ahead and differentiate. I can differentiate PB squared with respect to x. Okay, so I'm going to apply my power rule. So I'm going to say 4 times 1 is 4. Take 1 away from my exponent. 2 times -1 is -2. Take 1 away from my exponent, and I'm going to end up with that. And my constant term is going to end up with 0. When I am at a maximum or at a minimum, all right, my derivative, my gradient at a point, is going to be equal to 0. So you have to sub in 0. Okay, what we would end up doing here is taking out 2x, is that right? Double check myself. Oh, I suppose we would be dividing through by 2, wouldn't we? Okay, so if we divided through by 2, hang on a second, let's go back here, we would end up with 2x cubed minus x. All right, so now we're going to take out x as the highest common factor, and that is going to leave us with 2x squared minus 1. All right, so either x is equal to 0 or x squared is equal to 1 over 2. All right, so which means, now we're talking about distance, so we have to be talking about positives here. We can't consider negatives. Obviously, x can't be equal to 0 because it's not going to be 0 distance. Okay, so here we are going to consider where x is equal to the square root, positive square root, only 1 over 2, which you could then write as 1 over root 2. Okay, so now you need to go back and you need to calculate what PB or PB squared was. All right, so if you recall, PB squared, the original was x to the power of 4 plus x squared plus 1, it was minus x squared, sorry. Minus x squared plus 1. We would now go and sub in. And we would end up with 1 over root 2 to the power of 4 minus 1 over root 2 to the power of 2 plus 1. And that means you'd end up with an answer of 3 over 4. And of course, this is PB squared. So in order to get PB, we would then have to take the square root. So the square root of 3 over 4. So that would give us root 3 over 2. Okay, matrix. So yeah, that one was out of 7. That's a particularly difficult sort of question. Are you happy with that? Thumbs up, thumbs down.
Ma'am?
Yes, Karabo.
The part where you said D in brackets PP squared.
Yes, over
Is
dx.
Is that the formula for?
That's me taking that's me taking the derivative. Okay,
no.
so here I'm deriving. Okay, that's the notation for the derivative.
Okay.
Okay.
Okay, thank you.
No problem, Karabo. I'm glad you asked questions. Anybody else got any questions?
Ma'am,
Yes,
this is
Jaden.
gonna sound like I haven't been paying attention, but why did you derive?
Because we wanted to minimize the distance between Benny and the car. So we're deriving because we're talking about a cubic function here, all right? So in other words, if we were to graph what this looked like, all right, it would first be concave down and then it would be concave up. So if we want to minimize it, we need to be working with the value of x at this point. Okay, so when we derive, we work with the gradient at that particular point. So any tangent to the function at that point would have a gradient of 0, and that's why we've got to make it equal to 0. Okay.
Okay, I see now.
All right, no problem. If there are no more questions, I'm going to fly on to the next one. I think this is quite a nice question to do. So let's just talk about this and then we can move on and talk maybe about the financial maths. We might be able to fit everything in. Let's see, we'll push hard. Okay, so now here. This is your last question. So this is fundamental counting principle and probability. So a password consists of 5 different letters of the English alphabet. Each letter may only be used once. Very important. How many passwords can be formed if in 12.1.1 all the letters of the alphabet can be used? All right. So in other words, we have got 5 different blocks that we need to fill. But we're not allowed to repeat ourselves. So we could have a possibility of 26 in the first, 25 in the second, 24 letters in the third, 23 letters in the fourth, and in our fifth box, there could be 22 letters. Okay, so that would be 26 by 25 by 24 by 23 by 22. I worked that out earlier just to make life easier, but I can't remember what I've done with it now. Okay, so 26 times 25 times 24 times 23 times 22. What are you guys getting? Yeah, even me. Okay, I'm also getting 7, 8, 9, 3, 6, 0, 0. All right. Possible combinations that could be made. All right, in 12.1.2, the password must start with a D and end with an L. Okay, so what that means, I'll draw the boxes for you if that helps. There's 5 boxes in this case. 1, 2, 3, 4, 5. So there can only be a D in the first place. So that gives us one option here. There can only be an L in the last place. That gives us one option here. How many letters have we used out of the alphabet? 2. We're not allowed to repeat ourselves. So that means that there are 24 other letters left for us to use, because we're not allowed to repeat ourselves by 23. So we're not allowed to repeat ourselves by 22. So 1 by 24 by 23 by 22 by 1. Okay, so that gives us are you guys getting? Yeah, I'm getting the same answer. Well done. So 1, 2, 1, 4, 4 possible combinations. All right, good job. Okay, let's do the next one. They're talking about cars. They love objects arranged in a row. So let's have a look at this. Okay, so they've got 7 different cars, 3 of which are silver, are to be parked in a straight line. In how many different ways can all the cars be parked together? Okay, so now cars are like people. We obviously cannot repeat a car. Once it's been used and parked, it's there. So in 12.2.1, there would be 7 factorial ways in which we could park these cars. Okay, so 7 by 6 by 5 by 4 by 3 by 2 by 1. So 7 factorial is 5040. In 12.2.2, the best way to answer these sorts of questions where they want you to, so if the 3 silver cars must be parked next to each other, determine in how many different ways the cars can be parked. So if 3 things have to go together or 2 things have to go together, we do that and then we put them into their own group. Now we've got another, we've used 3 cars, 3 of them are sold, got another 4 cars. So I'm just going to use the letter C to represent car. So there's the 4th car, the 5th car, the 6th car, the 7th car. Okay, now we have to consider 2 things. How the silver cars can be arranged with one another, and how the silver cars together as a group can be arranged with the other 4 cars. So there are 3 factorial ways in which the silver cars can be arranged with one another, multiplied by 1, 2, 3, 4, 5 factorial ways in which they can be arranged with the other cars. Okay, so this would be 3 factorial times 5 factorial, which gives you 720. You're getting 720, guys? Move the chat and then I can see. Yes, okay. Indeed. Okay, does that make sense to everybody?
Ma'am?
Yes, Karavo.
So why aren't we timesing by the 7 since all of them are all together? Why aren't we adding the 7 factorial?
Because they've told us here, what we're doing differently now here is that we are grouping 3 of them together. So when we group 3 of them together, it's not 7 factorial anymore, because they can't just be arranged one after the other, because there is now an additional restriction. The 3 silver cars have to be parked next to one another. So we consider the 3 silver cars as one unit, right? Now, and then we look within that unit, and then we look how that unit is arranged with the others that are still available. Okay, so there are 3 factorial ways in which the silver cars can be arranged with one another. And now we're going to count this bubble, essentially this group of silver cars can be arranged in 1, 2, 3, 4, 5 factorial ways with the others. Okay, that's where it comes from. All right, a pleasure. Okay, let's fly on to the next question. Let's do the financial maths. Okay, this is a cool question. All right, so exactly 5 years ago, Mpumi bought a new car for 145,000. The current book value of this car is 72,500. If the car depreciates by a fixed annual rate according to the reducing balance method, calculate the rate of depreciation. Okay, so now, very important with financial maths, which formula are we talking about? Okay, reducing balance means we have to be working with
compound.
Yes, but A equals P 1 minus I to the N. Okay, I hope that's what you were all thinking as well. All right. So A is at the end, P is presently. Okay, so exactly 5 years ago, Pumi bought this car. What are we going to put in the place of A? Any ideas, Matrix? What goes in the place of A? So the 72,500. Are we happy with that?
Yes, ma'am.
Okay, I agree. So the 72,500 is what it's worth afterwards. In the beginning, when he bought it, it was worth 145,000. Good job. 1 minus the interest rate is what they want us to calculate. And they told us that Mpumi bought this car exactly 5 years ago. So this is going to be to the power of 5. They want us to calculate the rate of depreciation. So that means we need to calculate I. All right, first things first, let's divide both sides by P. So what I'm going to do now, just to make life easier for us, is I'm going to knock 2 zeros off there, and I'm going to knock 2 zeros off there. One of the mistakes that matrics make is that when they answer a question like this, the first thing that they pick up is your calculator. It's not. Put your calculator down, okay? You need your pen, not your calculator. You're going to calculate at the end, okay? So first things first, divide both sides by the value of P. So that's going to leave us with 725 over 1450. And we can leave it like that, is equal to 1 minus I to the power of 5. So to get rid of this power of 5, we've then got to take the fifth root. So the fifth root of 725 over 1450 is equal to 1 minus I. Now, the easiest thing for you to do here, matrix, is to bring the minus 1 over to the other side and bring this root over to the right-hand side. Okay, so when I move the I, the minus I, from the right to the left, it's going to become a positive I. And then when I move this over to this side, it will obviously become a negative. And now, and only now, do you pick up your calculators. Okay, so you're going to say 1 minus the fifth root of 725 divided by 1450. And you should be getting, I get 0,12944, blah, 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 blah. You're getting the same answer? So the rate times that by, 100, you should be getting 12.94%. Okay, Matrix? Okay. All right, good stuff. Now, let's go and have a look at the next question. All right, that is about a loan. All right, so Samuel takes a home loan for 500,000 and an interest rate of 12% per annum compounded monthly. He plans to repay this loan over 20 years, and his first payment is made 1 month after the loan is granted. So at least the conditions there are standard. Calculate the value of Samuel's monthly installment. Okay, because this is a loan, all right, we are going to be working with present value. All right, when we're talking about savings or some kind of retirement annuity, then it will be the future value. Okay, so present value in this particular case is 500,000. That is the present value of his loan. So that's P is equal to X, our monthly installment. 1 minus bracket 1 plus our interest rate 0,12 divided by compounded monthly divided by 12. Let me just move this over. Close bracket to the power of negative. It's going to be over 20 years. So 20 times 12 to the negative 240. Okay, all over I, which in this case is 0,12 over 12. Matrix, they will mark you for subbing into the correct formula. Do not waste your time trying to rearrange. At this stage now, pick up your calculator and work out what the value of X is. Okay, so we're going to do that by cross multiplying. So first multiply 500,000 with the denominator. So 500,000 times 0.12 over 12, and then divide by the square bracket. And then you can tell me what you get. And see if we get the same answer. I got 5,505 Rand and 43 cents. Do you guys agree? You get the same? Cool. All right, lovely. Good job, fine. Okay, so 4 marks there, right? There will be a mark for subbing into the correct formula, for working out what X is, definitely for the minus 240, and then for your answer. All right, next question, 7.22. All right, so it tells us that Melissa took out a loan for the same amount, the same interest rate as Samuel. Melissa's decided to pay 6,000 at the end of every month. Calculate how many months it took Melissa to settle the loan. Okay, so this is a question asking you to calculate in the number of payments, okay, because remember she's making 1 payment a month. Okay, so when we want to calculate in, they're asking us to calculate the exponent. They want us to use logs. Okay, so now this question becomes as follows. The present value of Melissa's loan is also 500,000. She's paying an installment of 6,000 Rand a month. 1 minus 1 plus, her interest rate is the same. But now we want to work out how long it's going to take Melissa to pay this off. Are we expecting her to pay it off sooner than Samuel, or is it going to take her longer to pay it off than Samuel? If you pay more every month, you're going to pay the loan off sooner. Exactly, Timothy. Okay, and save on interest as well at the end of the day. Okay, so now some more manipulations. What we need to do here, Matrix, is we need to cross multiply. So we're going to multiply the 500,000 with the 0.12 over 12, and then we're going to divide by 6,000. Okay, so on your calculators, you can calculate this 500,000 times 0.16 divided by 12 divided by 6,000. What does that give you? I got, when I did it, I got 5 over 6. You agree? Okay, I got the same answer as you. Okay, is equal to 1 minus, so 1 plus 0.12 over 12 to the negative n. And then I don't know about you guys, but this is what I always teach my boys. I take this term over. All right, so here I'm going to have my base, so 1 plus 0.12 over 12, that is 101. I'm just writing it as a fraction, 101 over 100 to the negative n, and it's going to be equal to 1 minus 5 over 6. So that means that we've got 101 over 100 to the negative n is equal to, so 6 minus 5 will leave me with 1/6. Okay, and now I'm ready to use logs. Okay, so either you can log both sides. I don't do that. I do this because I think it's easier. So my exponent minus n is equal to log my base 101 over 100 number. Okay, pop that into your calculator. I ended up with, and we want obviously a negative answer here. If we didn't get a negative answer, there would be a big problem because obviously time can't be negative. So we want, I ended up getting minus 180,07, whatever it was. So I would say in this case, n would be equal to 180. Okay, so it would take Melissa 180 months to pay off her loan.
Ma'am, do you have to convert the answer to like a specific, like
Not
months
if
or
they,
years?
no, Sake, if they didn't tell you to, then don't bother with it. Okay.
Yeah.
All right, so it will take Melissa 180 months. Okay, which is what we said we expected. Remember at the beginning, we said it would take Melissa less time to pay it off because she was paying more every single month. All right, and then that kind of ties quite nicely into the last question here, Matrix, where they ask us, who pays more interest? Samuel or Melissa? Justify your answer. Who do you think is going to pay more interest?
Samuel.
Samuel, exactly. Why is Samuel paying more interest?
Because he pays for a longer time than Melissa.
Perfect, Swelithli, 100%. Okay, so that would be your 2 marks there. Okay, so Samuel, because it takes him longer to pay off the loan. Okay, good job, well done. All right, we're flying now. We did that question. All right, I think the last question then that we had was this one over here, which I'm also happy to do with you guys. Okay, we've got 10 minutes left. Everybody okay managing? Is it all right? I hope so. Okay, so this also came out of a past paper. Thanks, Condisa. Can't remember which one. Anyway, it doesn't matter. Yeah, Timothy, we really are rushing, aren't we? Okay, we will not finish tonight with this not done. Okay, we will get it done before you guys go. All right, so a rain gauge is in the shape of a cone. Water flows into the gauge. The height of the water is 8 centimeters, where the radius is 7 centimeters. The angle between the cone edge and the radius is 60 degrees, as shown in the diagram below. Now, what is interesting in this particular question is that they've spoken about an angle. All right, they've told us that the angle between the cone edge and the radius is 60 degrees. All right, so the other thing that we notice, right, so that's this angle over here, is that it makes a right angle triangle. So in maths, certainly grade 12 level, whenever we are working in right angle triangles and they've given us degrees, they want us to work with basic trig ratios. All right, so if I was to redraw this triangle for you, not that I have to, but if I was to redraw this triangle for you, okay, like so, here is our 60 degrees, okay, over there, all right. Opposite is H, and adjacent to the 60 is R. So that means if they want us to determine R in terms of H, I hope you can see that. Do I need to maybe make that a little bit bigger? Where they want us to determine R in terms of H, we're going to have to use trig. Okay, so in question 10.1, sorry, let me just grab my pen again. In question 10.1, working in that right angle triangle, we would say that because it's opposite over adjacent, it would be the tan of 60 would be equal to opposite. So that would be H over R. So we want R in terms of H. That means make R the subject of the formula. So R will be equal to H over the tan of 60. And if you work out on your calculators, the tan of 60 would be root 3 over 1. Okay, so we would just write that as root 3. Everybody happy with that? Okay, so 2 marks there. Second part of the question, okay, so this is like the question about Benny, all right? We want to determine the derivative of the volume of water with respect to H when H is equal to 9 centimeters. Okay, so now they're asking us to derive with respect to H, and then they've given us what the value of H is going to be. All right, so now that means we need an expression for volume, all right, that we can derive. So if you have a look up here, they've given you all the formulae. You need to know which one is the right one to use. But nasty of them. But it's actually this one over here. This one is the formula of a cone. So volume is 1/3 pi r squared times height. So first of all, you have to select the correct formula. So volume is 1/3 pi, and then R is squared, but remember R in this case is H over root 3. That has to be squared times by height. So is everybody happy that I've subbed into the volume formula? What I'm going to do now is I'm going to remove, so that would be 1, hang on a second, ma'am, can a denominator be left as root? Yes. Yes, Selena, you can leave it. I know that they have taught you previously to rationalize the denominator, but they won't expect us to do this. And in fact, we're squaring it. So Selena, that root's going to disappear in any event. Okay, so I wouldn't even stress about it. All right, so here what we've got is 1/3 pi times h squared over 3 times h. So if we simplify all of this, guys, we're going to end up with 1/9, 3 times 3 is 9, pi h cubed. Are you happy with that? So that's going to be our expression for volume. All right, now we need to take our derivative. So we need to derive volume. We are deriving volume with respect to h. All right, so now I'm going to take my 3, I'm going to multiply it by 1/9. That's going to leave me with 1/3 pi, okay, because that's obviously my coefficient, h to the power of 2, because I'm going to take 1 away. Then they said to me that I needed to calculate the derivative of the volume of water with respect to H when H was equal to 9 centimeters. So they have now told me that I now need to go and make H equal to 9. All right, so now that I've got my derivative, I'm going to sub in my 9. And now I'm going to put that onto my calculator. Okay, whatever it gives you. So I'm getting I get 84,82 centimeters cubed in this case. You getting the same answer?
Yes, ma'am.
Thank you, Saku. Okay. Sure. Sayuri, what exactly did you not understand, Sayuri? Where did I lose you? From the very beginning, Sayuri, or from 10.2 onwards, or from where I took the derivative? At which point did I lose you, Sayuri? From the last bit with the derivative. Okay, all right. So Sayuri, they said to us here, they wanted us to determine the derivative of the volume with respect to H, when H was equal to 9 centimeters, right? So after I had found volume in terms of H, I now need to derive. So that's what I was doing here. I was taking the derivative of the volume with respect to H. So in other words, I'm applying my power rule. Okay, so I'm taking my 3 and I'm multiplying it by my constant. So when I say 3 times 1 over 9 pi, that's why I end up with 1 over 3 pi. Okay, then remember I've got to take 1 away from my exponent, and that's why I ended up with 2. Okay, so this is the step in which I am taking the derivative, I'm applying the power rule, and that's why I've used this notation. Right, then it was simply a matter of subbing in. They wanted me to determine the derivative when H was equal to 9. Okay, so now I just substituted. I made H equal to 9, subbed in, and then stuck it into my calculator. Okay, and then press the pi button, because otherwise my answer would have been in terms of pi, but I suppose that would probably also be okay. Whew, that was a rush. Okay.
Ma'am?
No problem. Yes, Jaden, go for it.
One last thing. Where did the 9 come from?
They gave it to us, Jaden, in the question.
Oh, okay.
Okay, because they said determine the derivative of the volume of water with respect to H when H is equal to 9. It was part of the question. Okay.
Okay.
No problem. Otherwise, you'd be like, where does this 9 come from? Yeah, no, it's because that's what they that's what they gave us. It's a pleasure, no problem. Well, that's it. Our time is up, guys. How's everybody feeling? How are you feeling about tomorrow? Nervous, anxious. Yeah, I can appreciate that. Scared, Bennett. Oh, Jaden, much better. Okay, that's good. Yeah, I understand that. Now, I know that it's a little bit late for us to discuss this, but you need to remember this matrix, okay? When you are scared or confused or worried or anxious, your brain can't do maths as well as if you are calm. So you have to, above all else, you have to stay calm. Do the questions you know how to do first. All the things that you are confident with, go and answer those questions first. It does not matter the order in which you answer the questions. It's unimportant. Do all the easy questions first. Highlight the questions that you didn't understand and come back to them again at the end. Okay, so it's quality over quantity. What you need to do is be careful. Okay, it's far more important to be careful than it is to be clever. Okay, so check yourself, read what you've written, check your answers. And if there are questions that you don't understand, don't let it throw you. Just leave it out and go and do the stuff that you know how to do. Okay. Always try and think, what rule can I apply? All right, there's got to be something that you've learned, some theory that you've learned that you can use. All right, and trust in yourselves. You've worked very, very hard. You know, I know all of us here at Watobe are 110% behind you, and we will be thinking about you tomorrow and yeah, waiting anxiously to hear about your results. Anyway, so I just want to wish you all of the very, very best. Thank you for being a wonderful group. Lots of love to you all, and good luck for the rest of your exams, especially your maths ones. Okay, I'm going to hand you back to Coco. Thanks, Coco.
Thank you, ma'am.
It's a pleasure.
Thank you, ma'am.
It's a pleasure, Sake. No problem. Good luck. Take care. Bye, Selena. Bye, Pearl. Bye, Chad. Bye, Timothy. Bye, Atankosi. Good luck. Well done, Sayuri. Good luck tomorrow. Pleasure, Jaden. Pleasure, Karabo. Cheers, Chad. Bye, Timothy. Bye, Jaden. Good luck, Fatima. Bye, Benedict. Bye, Swelile. Bye, Karabo.